Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I'm Dr. Muhammad Majid, and today we will again study the applications of Gauss's law. In our previous lecture, we have find out the location of extra charges on the conductors. So next today we will study the electric field intensity due to charge conducting spherical shell. This topic is on page number 25, electric field intensity due to charge conducting spherical shells. So electric field intensity due to charge conducting spherical shell. So what we would do here, we will find out the electric field intensity E by using the Gauss's law for a spherical shell. For example, we have a spherical shell of radius R, capital R, that is the center of the spherical shell, and that is a positive charge is distributed over the surface of the spherical shell. So how to find out the electric field intensity due to this spherical shell? So let's consider two cases. One is to find the electric field intensity at the interior पे electric field intensity क्या होगी by using Gauss's law, and the other is for the point outside the surface of the spherical shell. So let's consider we want to find out initially first case here at this point. So first one, electric field intensity E at the interior. Internal आपके पास electric field intensity क्या होगी? So again, let for example we want to find out the electric field intensity at this point P. तो हम क्या करेंगे? How to calculate? What we will do, हम एक Gaussian surface लेंगे just to simplify this problem. We consider a Gaussian surface, और मैंने आपको बताया था जो Gaussian surface है that is an imaginary surface, imaginary closed surface. So we consider a Gaussian surface in the form of the sphere, and let ये जो point P है it is on this closed surface, Gaussian surface पे है, और let इसका जो radius है इस स्पेयर का जो Gaussian surface है, let this is small r. So that is the case in which this r is less than this capital R, radius. तो interior क्या होगा? You can simply find out. It's very simple. We consider Gaussian surface in this. So as we know Gauss's law में पता है the electric flux through any closed surface, this electric flux E through any closed surface equal to charge enclosed per epsilon naught. And we know this thing. This is the net electric flux, total electric flux, like this, something E dot A, let it is E or EA. If you consider the theta equal to 0 for simplicity, this is Q by epsilon naught. So what we have studied in our previous lecture, electric field inside the conductor is 0, and again here Gaussian surface जो आपके पास है, इस point P पे आप find out करते हैं electric field intensity, and there is no net charge inside this surface. Clear? There is no charge enclosed inside this Gaussian surface. Remember, we consider this imaginary closed surface for the simplicity. So this charge enclosed here ये जो चार्ज इनक्लोज है, दिस इज 0 इनसाइड द गॉसियन सरफेस, देयर इज नो चार्ज इनक्लोज्ड आपके पास 0 है साइड द Gaussian surface. Remember, this is 0. So this Q is 0. Put it here like this equation 1. So equation 1 implies summation E into A equal to 0. Clear? Now area is not equal to 0. You know the surface area of the sphere, that is 4 pi r square. But this means sum of this area is not equal to 0. So what does this implies? This means E equal to 0. Clear? The same condition जो हमने पढ़ा था. Electric field intensity inside the conductor is 0 under electrostatic equilibrium condition. So this means this E is 0 at the interior. So that is the first case. Next, electric field intensity is the second case. Electric field intensity at the exterior. आउटसाइड अगर आप एक पॉइंट लेते हैं आउटसाइड द स्फेरिकल शेल, that you have any point, for example you wish to find out the electric field intensity here at this point, clear? So let me erase this one. This is radius r. Let you wish to find out the electric field intensity at this point P, and let it is at a distance r, small r, and in this case this r is greater than this capital R. So electric field intensity at the exterior, again how we will calculate? The idea is very simple. We will consider a Gaussian surface that is in the form of the sphere, but this time a bigger sphere. Clear? Now there is a charge enclosed Q. For example, इस spherical जो shell है, let यहाँ पे charge Q है. So in this case, the charge is enclosed. So how we will find? The same idea as we know. This is Gauss's law, Q by epsilon naught, and electric flux is EA, Q by epsilon naught. But in this case, charge enclosed is not equal to 0. You can find out simply. In this case, this Q is not equal to 0. So what we can write, summation E is constant. At this point, it's a spherical shell. So summation हम apply करेंगे for the whole surface. Whole surface is area आपके पास जो है, you know, this is Q by epsilon naught, और ये surface area जो sphere का है, you know, it is 4 pi r square, or is the radius of this spherical shell, equal to Q by epsilon naught. So what we get E is equal to 1 over 4 pi epsilon naught Q by r square. Clear? Where Q is the charge enclosed by this surface. So what we get the idea? If you remember, हमने electric field intensity find out की थी for a point charge using the Coulomb's law. Coulomb's law से हमने electric field intensity को find out किया था, और वहाँ से भी the same answer. If you have a charge Q और यहाँ से आप electric field intensity इस point पे find out करते हैं, so we have applied this formula. टेस्ट चार्ज अगर आप यहाँ पे रखते हैं, सो हमने फोर्स लिया था कूलम्स लॉ से, एंड वहाँ से Q1 Q2 डिवाइड बाय आर स्क्वायर, इफ दिस डिस्टेंस इज आर, तो हमने फाइंड आउट किया था द सेम रिलेशन. सो बोथ आर द सेम रिलेशन, रिमेंबर, जस्ट लाइक द पॉइंट चार्ज. इसका मतलब यही है कि आपके पास जो आंसर आता है दैट्स द सेम, कि ये चार्जेस जो है दैट इज कंसंट्रेटेड एट द सेंटर. For example, charge is Q that is concentrated at the center, and you wish to find out its the electric field intensity at point P. So the same answer just like the point charge. So that is for today. Next आप इसको वेक्टर फॉर्म में भी लिख सकते हैं, जिस तरह पिछले लेक्चर्स आप देख ले, वहाँ पे हमने इलेक्ट्रिक फील्ड इंटेंसिटी को वेक्टर फॉर्म में भी लिखा था। जैसे यहाँ पे एरो तो यहाँ पे फिर यूनिट वेक्टर आएगा। सो रिमेंबर दिस थिंग, इन आवर नेक्स्ट क्लास वी विल डू सम ऑफ द अदर एप्लीकेशन ऑफ द गॉसेस लॉ। सो दैट इज फॉर टुडे। ओके, बाय।